Hi everyone, this is Shruti Pandey from the Department of Chemical Engineering at IIT Kanpur, and I welcome you all to Lecture 3 of Polymer. So, till now, we have discussed the definition of polymer and the industries where polymer is used. We have also done the classification of polymers on the basis of various uh, parameters, and after that, we were basically discussing about the addition polymerization reaction. Okay, so just for a quick revision, I will quickly revise what we did in the previous lectures. So the term polymer is defined as very large molecules which are having high molecular mass, and these molecules they can also be referred to as macromolecules because they are very large. And these polymers they are formed by joining of the repeating structural units on a large scale. The repeating structural units they are simple and they are known as monomers. They are basically they repeat and they join together by the covalent bonds. This complete process of the formation of polymers is known as polymerization reaction. Now coming to the classification, I will just write down the names. So this is the classification of polymers. On the basis of. Okay, so I will only write down the names. We have already discussed them in detail. But if I discuss it again and again, it will be easy for you all to remember it. You even you don't need to learn these things. So first we did was on the basis of sources. Sources we had natural, then we had semi-synthetic, and then we have synthetic. Then on the basis of structure, we had linear, branched, and cross-linked polymers. Then on the basis of monomers, the number of monomers or the type of monomers you can say homopolymer or the homomer, where only one type of monomer is used, and copolymer, where multiple types of monomers are used. Then on the basis of molecular forces of attraction. So here these were important, and because these have very different properties, and commercially इस classification का ज़्यादा use है because of these properties they can be used in different applications. ठीक है बाकी sources structure monomer these are all I mean you can use them to classify the polymers, but they are not that useful from the application point of view. So elastomers, fibers, thermoplastics, and thermosetting polymers. ठीक है, elastomers are the polymers जिसमें कि the forces of interaction they are less, and because of that, because of this thing, the this property of elasticity exists in these polymers. ठीक है, so for example rubber, it is elastic. ठीक है, so it can be stretched when you apply force. On the other hand, fibers they have got a very strong forces of attraction, and so they are used in commercial fabrics. ठीक है, thermoplastics. ठीक है, when you on their preparation, when you increase the temperature, they will soften, and on decreasing the temperature, they will again harden. Okay, so they have this. I mean, if you take simply anything made up of plastic, suppose you take a water bottle cap, okay, so and when you heat it, okay, so it will melt. But when you remove it from the heat, you take it some distance apart, it will again, you know, freeze down. ठीक है, it will again cool down. वो हमेशा लिक्विड फॉर्म में नहीं रहेगा, ठीक है, तो सॉलिडिफाई कर जाएगा. So this is what thermoplastics have their property. Thermosetting is different in the way that after their preparation, they become heat resistant. Even if you heat them to the high temperature, they will not, they will not, soften. Soft नहीं होते, they will not melt. So basically, they are heat resistant. Then, on the basis of mode of polymerization, or you can say the mechanism of polymerization, we have addition and condensation. Because addition is also known as the chain growth polymerization, or condensation is also known as the step growth polymerization. So yesterday we were talking about the addition condensation. Sorry, the addition polymerization reaction. The chain growth polymerization. This addition or chain growth polymerization. Okay, so some of the important points that you should remember is that the molecules of the same monomer or the different monomers can also add together on a large scale. ठीक है, तो यहाँ पे होमोमर बनने का भी पॉसिबिलिटी है, और को पॉलीमर बनने का भी पॉसिबिलिटी है. ठीक है, को-पॉलीमर्स मीन यूजिंग द डिफरेंट monomers, different types of monomers. ठीक है, सेकंड पॉइंट इज द मोनोमर्स हियर दे आर अनसैचुरेटेड कंपाउंड्स, क्योंकि अनसैचुरेटेड कंपाउंड्स में ही एडिशन जो होता है वो इजी होता है. दैट इज व्हाई unsaturated compounds are used as monomers, for example alkenes, alkadienes and their derivatives. ठीक है, and these lead to the increase in the chain length, so that is why they are known as a chain growth polymerization reaction. Okay, so जो the most common mechanism is the free radical mechanism, which these kind of reactions they follow. So for the free radical mechanism, we were discussing there are three steps. So again, I mean, I'm not going to write down the complete steps because it takes a lot of time, but I'll just, you know, discuss it, what happens. So this is free radical mechanism. ठीक है, तो इसमें क्या होता है कि फर्स्ट ऑफ ऑल, you need a presence, you need a free radical generating initiator, which acts like a catalyst. So you should have free radical generating initiator. ठीक है? And examples can be benzoyl peroxide, acetyl peroxide, tert butyl peroxide, etc. ठीक है, तो we were doing the polymerization of ethene to polythene as an example. So what happens is we simply heat the mixture of ethene with a small amount of benzoyl peroxide initiator. So for this particular reaction, polymerization reaction, that is converting ethene to polythene, we use benzoyl peroxide as a catalyst. So here I will mention it. Okay, I'll mention it at the end because both the kinds of reactions are there. So, so basically, when we are talking about homopolymerization, ठीक है, तो उसको हम बोलते हैं होमोपॉलीमर या फिर होमोमर भी बोलते हैं. ठीक है, इसमें the reaction that we'll be talking about is ethene to polythene. ठीक है, so the first step here is the chain initiation. Chain initiation में क्या होता है कि जो हमारा benzoyl peroxide होता है, which is basically taken here as a catalyst, it is an initiator, so it breaks down first into the benzoyl radical and then into the phenyl radical. Phenyl radical is 2 C6H5 radical. ठीक है, so this is a phenyl radical, and then this phenyl radical is simply adds up to the ethene molecule, to a single ethene molecule, to form the another larger free radical. ठीक है, तो पहले स्टेप में ये दो चीजें हो रही हैं. This is known as a chain initiation step. Then we have chain propagation. Initiation मतलब start होना, propagation मतलब continue होना और बढ़ना, कोई चीज propagate हो रही है. So chain propagation step. ठीक है, now when it has already formed this radical which was formed in the first step, it now reacts with the another molecule of ethene. ठीक है, अब वो बहुत सारे molecules of ethene पे subsequently react करेगा, and then the bigger sized radicals will be formed. ठीक है, and this step will be repeated. So basically अलग अलग ethene molecule के साथ में add होगा, and the chain will be getting bigger and bigger because of this addition. So this is the chain propagating step. तो यहाँ पे जो chain length होती है chain propagation step में, वो chain length बढ़ रही होती है. ठीक है, and at last we have chain terminating step. Here what happens that after some point of time, ये जो product radical बनता है in the last step, in the previous step, it reacts with some other radical which is being formed somewhere else in the mixture. ठीक है, तो अलग अलग जगह पे reactions हो रहे हैं, अलग अलग जगह पे chain growth हो रही है. ठीक है, तो कोई भी दो जो radicals होते हैं, they react with each other. ठीक है, ethene molecule से reaction नहीं होता, तो two radicals react with each other. So that point or that definition is known as chain terminating step. ठीक है, बिकॉज दो रेडिकल्स जब आपस में एड अप होते हैं, तो वो फाइनली आपको एक सैचुरेटेड प्रोडक्ट दे देते हैं विच इज नॉट रिएक्टिव. ठीक है, what happens in the chain propagation step is we are again and again getting a free radical, bigger and bigger radical, and it is again reacting because it is reactive species. ठीक है, so this was for the steps. Now, if you want to write out the final reaction of ethene getting converted to polythene, we can write it in this way. So, ethene is CH2, CH2, double bond. ठीक है, एंड आपको यहाँ पे N लगा देना है because you are just to show कि there are a large number of molecules which are participating. Here I am using benzoyl peroxide as an initiator. And finally, what you will get is CH2, CH2. And I told you कि when some this is a monomer over here. ठीक है, तो this thing is repeating or again and again in the chains. तो इसी वजह से we simply put that bracket along that monomer and put this N as a subscript. ठीक है, तो ये जो N है that is simply denoting कि there are a large number of molecules taking part in the reaction. So this is what polythene will be formed. But here I would also let you know that यहाँ पे homomer के साथ में there is a chance, I mean this copolymers भी बनते हैं. तो copolymer में we also did an example and that was Buna S. ठीक है, तो I will simply write down the reaction over here. N CH2 double bond CH CH double bond CH2. So this is what? This is 1, 3 butadiene. Again, this is 1, 3 because there are 4 carbon atoms. So butadiene. क्योंकि हम यहाँ पे डबल बॉन्ड की पोजीशन बता रहे हैं. See, 1 and 3 is the double position of the double bond. So this is 1, 3 butadiene plus N C6H5 CH double bond CH2. Okay, this is styrene. Okay, and after the reaction, these two will combine or add up to give this species CH, CH2, again CH, CH2, this is C6H5 N. Okay, so this is Buna S. As I told you how to remember, कि Buna S is a kind of rubber. So what are the monomers involved in the formation of Buna S? From Buna, it will be 1, 3 butadiene because it is Bu. So you can remember it like that. कि Buna मतलब 1, 3 butadiene and S it is for styrene. Okay, so that is how you can remember the names of the monomers. Now coming to, we will now study or discuss about the different kinds of important addition polymers. ठीक है, we will only do 3 or 4 of them जो कि सिर्फ addition polymers हैं. ठीक है, तो we will do everything. We will discuss everything in detail about them, like what is there, what are the conditions of the polymerization reaction and what are the catalysts being used. Also, what are their properties and applications. Okay, so that will be in detail. So we will start by polythene today. Important addition polymers. Okay, so the first one we will start with is polythene. Okay, now as I told you, the other polythene is consisting of the long chain molecules and उनकी जो property होती है, I mean according to their property they come under thermoplastic polymers. ठीक है, thermoplastic polymers मतलब they are capable of repeatedly softening on heating and hardening on cooling. ठीक है, उनकी properties they change with the temperature. ठीक है, so they will again and again soften on heating and again harden on cooling. So this is what the thermoplastics do. Okay, so basically there are two kinds of polythene. The low density polythene, which is known as LDPE in short, and the high density polythene, which is known as HDPE in short. Okay, so the main differences which lie in both of these polythene, it is because of the conditions of polymerization. By conditions, I mean the temperature and the pressure, which is used for this during this reaction. Then the catalysts which are used. Okay, so because of these things, the product that we are getting has a different structure overall. तो देखिए क्योंकि जब कंडीशंस ही डिफरेंट है और काफी डिफरेंट है तो बिकॉज ऑफ दैट स्ट्रक्चर भी काफी डिफरेंट होता है एंड बिकॉज ऑफ दैट द properties also differ a lot and they can be used in different applications. ठीक है तो first we will start with low density polythene. The reaction I have already told, I mean discussed in the previous slide. ठीक है, this is using the addition polymerization reaction. It will look something like this, but we will now discuss this in detail. ठीक है, तो इसका भी जो A है, I will write it down as A because it is part of polythene. So this will be low density polythene. ठीक है, so first of all, conditions of reaction. Okay? Conditions मतलब generally हम temperature pressure की बात करते हैं कि what are the conditions which are used. So for this case, the high pressure of 1000 to 2000 atm. ठीक है, this is the high pressure and temperature of 350 Kelvin to 570 Kelvin. These are the temperature and pressure key conditions. Then coming to the catalyst. So either in the presence of traces of oxygen, ठीक है, so it is either done in the presence of traces of dioxygen or a peroxide initiator. ठीक है, so what we did in the last lecture, the whole addition with the free radical mechanism that we did using the peroxide initiator. So basically that was for low density polythene. Or a peroxide initiator as a catalyst. So these are the these two can be used as a catalyst over here. Now we come to the structure. So because the mechanism involved is free radical addition and the hydrogen atom abstraction. Okay, so it is a highly branched structure. Okay, so because of all these of the mechanism and all, structure is basically आप ये भी लिख लो कि it is using the free radical mechanism plus hydrogen atom abstraction. ठीक है, so because of this highly branched structure बनता है. I will draw the structure also. तो हाईली ब्रांच स्ट्रक्चर मतलब कि ऑब्वियसली स्ट्रेट ये हमारे ऐसे ऐसे करके चेन्स होंगी, बड़ी बड़ी लंबी लंबी पॉलीमर की, है ना, ऐसे ऐसे रैंडम, और उसमें बीच में से ब्रांचेस होंगी, ऐसे करके। ठीक है, तो इसको हम लोग बोलते हैं हाईली ब्रांच स्ट्रक्चर, के चेन्स होंगी बट बीच में ब्रांचेस होंगी। ठीक है, नाउ कमिंग टू द प्रॉपर्टीज, इट इज दिस पार्ट इज वेरी इंपॉर्टेंट, एंड बिकॉज ऑफ दिस लेट मी टेल यू, बिकॉज ऑफ दिस हाईली ब्रांच स्ट्रक्चर द डेंसिटी बिकम्स लो। क्योंकि आप ऐसा समझो कि जब चेन्स के बीच में ब्रांचेस होंगी तो चेन्स दूर दूर होंगी। ठीक है, सो बिकॉज ऑफ दीज, आई मीन यू कैन थिंक ऑफ अ ट्री विच हैज अ लॉट्स ऑफ ब्रांचेस। So, so in that tree, the main branches जो होंगी, they will be, far away from each other. So because of this large distance of these two branches, of these two polymer chains due to the branches, the density becomes low. The overall density is low. So that is why the name is low density polythene. So I say, yeah, I mean this is a way you can remember it. Then coming to the properties. For properties, some of the important properties here are that it is chemically inert. ठीक है, it is chemically inert. Tough but flexible. So because of the low density thing, this is flexible. And some other point is it is a poor conductor of electricity. Okay? So these are the important properties. And coming to the applications, or simply we can write uses. Uses होती हैं insulation of electric wires, क्योंकि वो poor conductor है, so that is used, that can be used because of this property. Electric wires, and for the manufacture of waste bottles or the toys, flexible pipes. See, some pipes are tough. Okay, but like pipes which are used for filling water and all, that is that those pipes are flexible. Okay, so for the manufacture of bottles, toys, and flexible pipes. So this was all the information about the low density polythene. Second, and we will do the similar analysis or a similar kind of a discussion for the high density polythene also. Okay, basically this can be kind of a difference. So if in the exam, they can also ask a theoretical question that what are the major differences between the high density and the low density polythene. ठीक है, तो जैसे मैंने यहाँ पे लिखा है ना, ये like on the basis of the conditions of reaction, catalyst, structure, properties and uses. तो आप उसको उस you can divide that answer into these points and show the differences. So next we will come to B part, which is high density polythene or HDPE. ठीक है, तो similarly we will do over here also. First would be conditions of reaction. तो प्रेशर हियर इज वेरी लो, जैसे वहां पे क्या था, वो बहुत ही हाई प्रेशर यूज किया जा रहा था, बट यहाँ पे प्रेशर इज वेरी लो, pressure of just 6 to 7 atm. That's it. And the temperature is also less as compared to the previous one. So it's 333 Kelvin to 343 Kelvin. That's it. ठीक है, so both temperature pressure तो बहुत ज्यादा कम है, ठीक है, but temperature is, I mean, not is lesser than that, but almost, you know, comparable. After conditions, we come to catalyst. So catalyst used here is very complex catalyst. I will write down the name. So, in the presence of a catalyst, it is triethyl aluminum, triethyl aluminum is one thing, and titanium tetrachloride and titanium tetrachloride is another compound. ठीक है, these two are the different compounds. उनको combine करके catalyst use होता है, and the name of that catalyst, ठीक है, is basically uh, Ziegler-Natta catalyst. ठीक है, तो I mean, I can also write down the formula, like how can you represent. So first, see, it is triethyl, so it is 2 C2H5, which is ethyl, right? C2H6 is ethane and C2H5 is ethyl. So triethyl and then aluminum. Okay, so this is how you represent the first compound, plus the second compound is titanium, which is Ti tetrachloride. Cl is chloride, tetrachloride is TiCl4. ठीक है, so this is titanium tetrachloride, and उसको combine करके we give it a name. ठीक है, इन दोनों कंपाउंड्स को कंबाइन करके we give a name of the catalyst, which is known as Ziegler नाटा कैटलिस्ट. ठीक है, नाम बस कुछ नहीं है, ये दो कंपाउंड्स हैं अलग अलग, और उनको कंबाइन करके वी यूज देम एज अ कैटलिस्ट. ठीक है, तो दिस इज नोन एज अ जीगलर नाटा कैटलिस्ट. ठीक है, एंड दिस इज डन इन द प्रेजेंस ऑफ एन हाइड्रोकार्बन सॉल्वेंट. ठीक है, सो दिस इज एन एक्स्ट्रा थिंग ओवर हियर. फिर दिस वाज द कैटलिस्ट, देन वी कम टू द स्ट्रक्चर. So it consists of linear chains. ठीक है, जैसे वहां पे ब्रांच चेन्स था, यहाँ पे लीनियर चेन्स होती हैं विदाउट ब्रांचिंग. I will write here without branching. And they have a high density due to the close packing. So these are the closed linear chains without branching. And because of their closeness, ये वो सिर्फ linear chains होती हैं, so and they are closed, they are very close to each other. ठीक है, तो because of the close packing, high density हो जाता है. High density, ठीक है. So basically, if you want to draw the structure, I mean, ठीक है, these can be the linear chains without any branching. So because there is no branching, so these chains, they are very close to each other. They are closely packed, and because of things, the density becomes high. So that is why the name is high density polythene. So structure हो गया. Then we have properties. So because of this structure, some important properties first of all, they are also chemically inert. So this is a, this is not a difference. This is a similarity. This is also chemically inert, but they are more tough and hard as compared to LDPE. And this toughness and this hardness is because of the density thing. ठीक है, you must understand कि जितना ज़्यादा dense होगा उतना ज़्यादा मटेरियल टफ होगा और हार्ड होगा. ठीक है, केमिकली इनर्ट एंड मोर टफ एंड हार्ड. सो दैट इज वाई इन सारे प्रॉपर्टीज की वजह से जो यूजेस हैं दे आर ऑल्सो वेरी डिफरेंट हियर. ठीक है, जैसे कि दे कैन बी यूज फॉर मैन्युफैक्चरिंग बकेट्स, डस्टबिन, हार्ड बॉटल एंड डिफरेंट टाइप्स ऑफ पाइप. ठीक है, एंड एक्सेट्रा. ठीक है, तो इवन इफ यू हैव सो मेनी यू नो examples of polythene, I mean you can find so many examples of polythene around you itself. Okay, but the type of polythene, the type of actual type of material is very different for each of them. Okay, so there are many uh, different types of polythene, but these are the two main. Okay, so this was the two kinds of polythene, high density and low density, and their major things or the major points that you should remember. Okay, as a part of the differences between these two. Next, we will move on to the next addition polymer. One was polythene, and then we have second, which is known as Teflon. But we will Teflon is the that's the second name. Originally, it is poly, tetra, fluoro, ethene. Okay, and it is also known as Teflon. Okay, so basically, I mean, from the name only you can see कि जैसे हमने ethene से polythene बनाया. So what was there? I mean, from the name itself, you can see कि monomer was ethene. आप बस poly हटा दो, बाकी else would be the monomer. So similarly, in the case of addition polymers, ये चीज बहुत common होती है. The type of naming is very similar. So here also you remove the poly, so the monomer would be tetrafluoroethene. तो यहाँ पे क्या होगा? Monomer is just remove poly, so you will be left with tetrafluoroethene. Second, this is the monomer. Now you heat this tetrafluoroethene with a free radical or a persulfate catalyst at the high pressure. Okay, so basically, uh, if we talk about condition, then it would be high pressure. The heating at high pressure and जो catalyst होता है that is free radical or a persulfate catalyst. Okay, talking about the properties, chemically inert, and resisted to attack by the corrosive reagents. Okay? So these are the two main properties, and because of this resistance by the from the corrosive reagents, it is used. जो applications है वो भी वैसे ही है उसी type की. Uses क्या है? Making the oil seals and the gaskets, and non-stick surface coated utensils क्योंकि वो resistant होते हैं. Non-stick surface. I mean, we are talking about the kitchen utensils. You have the non-stick pan and the different kinds of non-stick utensils. So those. Okay, so these are the main uses. Now, how to write down the reaction? So, see, tetrafluoroethene is tetrafluoro. So, from the name, you can see you have four fluorine molecules. Fluoro is F. Okay, so there are four fluorine molecules and then you have ethene. ठीक है तो इथीन क्या होता है इट इज CH2CH2 ठीक है but now you are putting four fluorine molecules so all the four F molecules they will replace sorry they will replace the H molecule ठीक है तो क्या होगा CH2CH2 की जगह पे it would be CF2CF2 ठीक है टेट्रा फ्लोरो मतलब चार फ्लोरीन एटम्स इन इथीन so you are replacing all the H atoms by F atoms so this would be CF2 double bond CF2 ठीक है एंड एन लगाना बहुत जरूरी है फॉर द केस ऑफ रिएक्शन so this is the monomer tetrafluoroethene ठीक है now what you require first thing you require is a catalyst and second thing you require is high pressure ठीक है and the product would look like because as I told you in addition में क्या होता है कि जो double bonds होते हैं mainly in unsaturated compounds so there would be double bonds and these double bonds they are opening I mean one double bond will break down and the two electrons which were participating in it they will move to the अदर साइड ठीक है वो मैंने लास्ट टाइम पे डिटेल में एक्सप्लेन किया था कि हाउ यू कैन रिमेम्बर कि हाउ द बॉन्ड्स विल ब्रेक डाउन एंड व्हाट विल बी द फाइनल प्रोडक्ट सी इफ यू सी द मैकेनिज्म प्रॉपर्ली you you will not you will not require to rectify anything ठीक है आपको खुद ही पता है इफ यू नो द मोनोमर यू कैन डायरेक्टली ड्रॉ द पॉलीमर ऑन योर ओन ठीक है इफ यू नो हाउ द बॉन्ड्स आर ब्रेकिंग एंड हाउ द न्यू बॉन्ड्स आर फॉर्मिंग it is again CF2CF2 and those electrons they will be over here ठीक है and because this thing is repeating we will simply write it as N over here and this is Teflon okay so this was all about the second addition polymer that is Teflon then we will talk about one more addition polymer that is polyacrylonitrile okay this is polyacrylonitrile so the this is also I mean we are discussing the addition polymerization so here also you can say कि यहाँ पे poly हटा दो remove this poly word and you will get the monomer. So same here also. The monomer is acrylonitrile. monomer is acrylonitrile. ठीक है, and the catalyst here is a peroxide catalyst. So the reaction is happening in the presence of a peroxide catalyst. ठीक है, peroxide क्या करता है? Initiation of free radical. And we will get the final product. So talking about the uses, it is used as a substitute for wool in making the commercial fibers. ठीक है, तो यहाँ पे हम लिखेंगे uses में it is used for making the commercial fibers. Fibers मतलब fabrics like orlon or uh, acrylan. Yes, so these are the commercial fibers. These are used as a substitute for wool. So I will also write down that point. ठीक है, and then we will write down the reaction. इसमें ज़्यादा कुछ नहीं है. So see, acrylonitrile. Nitrile, from the organic chemistry, you must be aware of that nitrile मतलब CN, CN functional group. ठीक है, और here also this is also from ethene. जैसे हमने क्या किया था, इथीन से टेट्राफ्लोरोइथीन बनाया था, वैसे ही हम इथीन से ही एक्रिलोनाइट्राइल बनाएंगे. ठीक है, सो द पेरेंट कंपाउंड इज इथीन. तीनों में ही इथीन का यूज हो रहा है. तो यहाँ पे क्या होगा, इन द इथीन मॉलिक्यूल विच इज CH2 double bond CH2, you will replace one hydrogen atom by the CN molecule or the CN functional group. ठीक है, so only one hydrogen atom is replaced and you get the monomer. So monomer is like this, CH2 double bond CH2. So one H will be intact and the other H will be replaced by CN. ठीक है, यहाँ पे आप N लगा दो. This is a polymerization reaction. Peroxide as a catalyst. And finally, what you will get is CH2, CH, CN, N. ठीक है, so this is polyacrylonitrile. और उसको short, I mean somewhere in the some standard books you can also find this PAN short form. But you may not find it everywhere. ठीक है, people use it to PAN to call it as polyacrylonitrile. ठीक है, तो here अगर मैं स्ट्रक्चर बनाऊं तो दिस विल बी समथिंग लाइक दिस. ठीक है, जैसे यहाँ पे 2 H हैं, यहाँ पे एक CN है और एक H है. ठीक है, so one H on this side is replaced by CN. So this is acrylonitrile group. So this was all about the addition polymerization reactions. ठीक है, so we studied about polythene, we studied about polytetrafluoroethene, and we studied about polyacrylonitrile. ठीक है, in सब में the similarity is, first of all you remove the poly, so the name would the rest of the name would be the name of the monomer. तो कुछ अलग से याद नहीं करना है. ठीक है, you just, and also you must remember कि all of these three monomers they are from ethene only. ठीक है, तो बेस चीज है वो ethene ही है. Next we come on to the condensation polymerization, which is also known as the step growth polymerization. ठीक है, so this I have already introduced when we were doing about the classification of polymers on the basis of polymerization. So there we discuss the differences. So the important points here is that two bifunctional or the trifunctional monomeric units are there. ठीक है, तो फर्स्ट ऑफ ऑल जो एक यूनिट है, जो एक पर्टिकुलर यूनिट है मोनोमर है, वो खुद ही अपने में बाईफंक्शनल या फिर ट्राईफंक्शनल होगा। तो जस्ट टू एक्सप्लेन व्हाट इज बाईफंक्शनल मीन्स इट इज हैविंग मोर देन मतलब इट इज हैविंग टू फंक्शनल ग्रुप्स। मतलब those two functional groups can be you know they can be alcohol, they can be acid, हाँ, and one more thing, टू फंक्शनल ग्रुप्स का मतलब ये नहीं है कि एक ही कंपाउंड में या एक ही यूनिट में यू हैव डिफरेंट टाइप्स ऑफ फंक्शनल ग्रुप। टू फंक्शनल ग्रुप मतलब even if there is a hydroxy group, there will be two hydroxy group in that compound. Even if there is a carboxylic acid group or an aldehyde group, they will be two aldehyde groups in the same compound. ठीक है, तो बाई फंक्शनल मतलब ये बिल्कुल भी नहीं होता है कि दोनों जो ग्रुप्स हैं, फंक्शनल ग्रुप्स हैं, वो दोनों अलग अलग ही हों। दे कैन बी सेम ऑल्सो। बस दो होने चाहिए एंड ट्राई के केस में तीन होने चाहिए। ठीक है, तो एज अ नेम सजेस्ट, कंडेंसेशन रिएक्शन में और स्टेप ग्रोथ रिएक्शंस में कंडेंसेशन होता है, मतलब एज अ रिमूवल ऑफ सम स्मॉल मॉलिक्यूल, सिंपल मॉलिक्यूल्स होते हैं उनका रिमूवल होता है। ठीक है, so this is just the introduction, but the proper understanding of the condensation polymerization with the examples. We will also discuss, there are a lot of examples in condensation reactions. So we will discuss the examples in the next lecture. This was all for today. Thank you, class.